Hello, this is CP Adept and welcome to yet another video of our August LeetCoding Challenge series. And today's problem is sort array by Parity. So in this problem, we are given an array and we have to sort it according to this given condition. And the condition is that all the odd elements must come after the even elements and their relative order doesn't matter. It is saying that if there are elements 3, 1, 2, 4, all the even elements such as 2 and 4 must come before all the odd elements. So the outputs 4, 2, 3, 1, 2, 4, 1, 3 all are accepted. So what we can notice in this problem is that we can apply sorting algorithm according to our comparator. So in that comparator, we'll be setting that if the first element is even, it should come before the second element, and uh, vice versa. So that solution is also a good solution, but we are said that the relative order doesn't matter, so we probably don't need sorting. So in this problem turns out to be exactly similar to another problem where we need to sort an array of zeros and ones. So the array contains zeros and ones and we have to sort it, and it can be done in linear time. So there are multiple ways to solve this problem. So first solution we discussed was according to sorting, and that gives us the complexity of n log n. So we can do it in O(n) time. So what we can do is we can create another array, and then we'll start placing all the odd elements in that array first, and after that we'll be placing all the even elements. So this is also a linear time solution, but we can do much better. Like, we don't need two passes of the original array. So what we can do is we can place two pointers, one pointer at the initial element and last pointer at the and second pointer at the last element. So we can maintain a loop invariant that all the elements before the start and after the end pointer, what you say, this pointer, are already in their correct position. So if I is at 3 and j is at 4, then we can say that all the elements before 3 and all the elements after 4 are in their correct order. So to maintain this loop invariant, what we can do is, if the element at ith position is already even, we can increment I, and if the element at j is already odd, we can decrement j. So we are moving I and j towards each other at each point. And if there comes a point where these elements are different, like the element here is odd and element here is even, we can swap them, and then we can again check the conditions. So if you don't know what a loop invariant is, go and check out what a loop invariant is. But the idea is to maintain a loop invariant for this given condition. So what we are doing here is we have maintained two pointers, I and j. I is at the initial point and j is at the last element, and while I is less than j. So that means if there are more elements between I and j which may not be in their correct positions, we are checking if the current element is even. The current element at ith pointer is even, we can increment I, and if the element at j is odd, we can decrement j, else we can swap them. At the end we are just returning the array, which is a, because we are doing everything in a. We don't need to create another array. So let's try to submit it. So I hope you understood the problem, and if you have not, I would strongly recommend you to solve the problem to sort zeros and ones in an array in a single pass based on the similar concept. And I would also recommend you to solve another problem which contains 0, 1s and 2s, and you need to sort them in such a way that all zeros come before ones and twos and all ones come before the twos. So I would recommend you to solve both these problems, and it would be really fun to solve. So let's see you in another video. Please like, subscribe our channel. Thank you.